All right, welcome to lesson 97. This is similar triangles. And then we're also going to talk about indirect measurement, which is a way to measure something, surprise, indirectly. So you're not going to actually measure that length. You're going to use some other lengths to figure out what it is. We're starting with similar triangles, which, as you remember, are different from congruent triangles. So here we have a set of similar triangles. I know that they're similar because in similar triangles, I know that corresponding angles are congruent. So you should be remembering that corresponding angles are congruent. So for example, I have those two angles are congruent to one another. My right angles are congruent to one another. These angles are congruent to one another. So I know because of that my two triangles are similar, but they are different sizes. Corresponding side lengths, so for example, this side would correspond with this side. Those are corresponding sides. Those side lengths are proportional to one another, meaning each of these sides can be multiplied by the same number to get your second side. So in this triangle, it's actually pretty simple. This triangle, I've doubled my 6 to get 12 feet. That means that for the 5 feet, if I double it, that is going to be the length of this side here. So this side length is 10 feet. My smaller side length, well, this guy's double, so that means that this side length would be 4 feet. I cut it in half. They won't always be as simple, though. For example, this triangle. So find a set of corresponding sides. So I know I have this guy is 10, this guy is 6. Well, there's nothing really, not an easy number to multiply 6 by to get 10. So what we're going to do instead is we are going to set up a proportion. There's lots of correct proportions that you could do. I like to start up and say, well, I have 10 over 6. So 10 corresponds with the 6 in the smaller triangle. Then let's find the side that we want in our larger triangle. So that would be A, which matches up with 3. So if I do 10 over 6, then I'm going to jump back up. I'm going to do A over 3. So I get 10 over 6 is equal to A over 3. Cross multiply. You get 30 is equal to 6A. Divide by 6, which means that A is going to be 5. All right, well, so let's find out our other side that we don't know. They didn't label it. Let's call it a B. Set up a proportion again. So I'm going to start again with that 10 and 6 because I know that 10 over 6 is going to be equal to, I'm going to jump back up, to B over 5. Cross multiply again. And so you get 50 is equal to 6B. Divide by 6 on both sides. That one doesn't come out to a whole number, but that's okay. You get that 6 goes into 50, goes in 8 times, and there's 2 left over, so you get 8 and 2 6, which is equal to 8 and 1/3, equal to my B. So we can use proportions to find missing side lengths in similar triangles. Next problem. We're going to have similar triangles again, but you have to set up those similar triangles. So they're going to give you a situation, you're going to draw some triangles. So in this one, Eden is 5 feet tall. So we have a picture of lovely Eden right here. She's 5 feet tall, and her shadow is 6 feet. So I'm going to draw a shadow of 6 feet. A nearby tree casts a shadow of 30 feet. So this guy is 30, and we want to know how tall the tree is. I'm going to say H for the height of the tree. We can use proportions again to find this. It's not easy to measure the height of the tree. This is indirect measurement. So we're going to use the triangle that we do know in order to figure out the triangle that we don't know. So my proportion, well, I know that 5 matches up with H. They correspond to each other. So I'm going to say 5 over H is equal to 6 over 30. So then I get that 6H is equal to 150. Divide by 6 on both sides. And 6 goes into 150 25 times. So I get 25 is equal to H. And my answer was in feet. So the tree is going to be 25 feet tall. Sometimes they'll give you a situation and you will have to set up the triangles yourself. So here we go. Devin measures the shadow cast by a light pole. Okay, so we've got a light pole. Here's my little light pole, and it's casting a shadow. So the shadow is 24 feet. And then she holds up a meter stick, and its shadow is 40 centimeters. So we get 40 centimeters here. Well, this was in centimeters, so we need this length to be in centimeters, so that they match. Well, a meter is equal to 100 centimeters. So I'm going to label this as 100 centimeters. This one was feet. We can still set up a proportion, and our answer here will be in feet. So these two units match, these two units will match. We're trying to find out how tall the light pole is. I'll go ahead and call this h again for the height. Set up a proportion. And there are multiple proportions you could use. You could do h over 100 equals 24 over 40 and go that way. You could do h over 24 equals 100 over 40. You could do 40 over 100, 24 over h. There's a lot of correct ones. As long as when you cross multiply, you get the same thing, you should be good. I'm going to set up corresponding sides. So I like to start and say h over 100 because I know that those sides match up with each other. They correspond. And I'm going to say equals 24 over 40. Cross multiply, you get 40h equals 2400. Divide by 40. And then h is going to be equal to 60. And then remember that this was in feet, so then my units is going to be feet. So that light pole is 60 feet tall. Here's where I want for you to pause the video. You have what you need for 3, 4, and 5. Go ahead and try those out. Pausing the video so you don't see the answers. Josh. All right, so here are the answers for 3, 4, and 5. If you have them right, then awesome. You can stop the video. If you don't have them right, I'm going to go through each of them. So for this one, we need some corresponding sides. The ones that I do know that match up are the 6 and the 9. So I'm going to start there. So I would start with 6 over 9 is equal to, let's do the x first. So x matches up with 12. So then I cross multiply. I get 6 times 12 is 72 equals 9x. Divide by 9, that means 8 is your x. Let's start again and do the same thing for the y. So I get, if I start with a small triangle, then I have to start with the smaller triangle again. So I get 12 over y. And so then I get 6y is equal to 9 times 12. I don't know that off the top of my head. Equals 18, which equals 108. Then divide by 6. 6 goes into 108, goes in 648, 6 times 8, so it goes in 18 times. Y would be equal to 18. On this one, we need to actually draw the picture. So a tree casts a 18-foot shadow. I'm not the best artist, so we're going to draw a lovely tree here. And it casts a shadow of 18 feet. And then we have a pole that is 6 feet tall, and it casts a shadow 9 feet long. How tall is the tree? So this is the height, this is the thing we're trying to find. So I would say h over 18 equals 6 over 9. You can cross multiply, or you could also note that, hey, 18, I've cut it in half to get 9. So what do I need to cut in half in order to get 6? And that would be 12. Or you can go through the process of actually multiplying, where you would get 9h is equal to 108, and then divide, and you'll still get 12. Excuse me, and your unit would be feet. Last one. This one was maybe a little bit harder. So he notices that you've got this basketball hoop, right? And he notices that the shadow is twice the length of his shadow. We don't know how long the shadow is, but we do know that CJ is 6 feet tall. We don't know his shadow. We know that this shadow is double, so I'm going to call that 2x. So here's the same principle with the very first triangle that we did, where we have one side length double the other one. That means every side length is going to be double. So if I have a height of 6 for CJ, that means I'm going to have a height of 12 for my basketball hoop.